we discuss chapter 4 capacitor. Okay, number 1. When a cylindrical capacitor is given of 0.5 nanocoulomb, a potential difference of 20 volt is measured between the cylinders. What is the capacitance of this system? So we take out the Q equal to 0.5 nano, negative 9 coulomb, and the potential difference is 20 volt, and then we need to calculate your capacitance. So we use the formula of C equal to Q over V. So substitute, divide with 20, so we get C is equal to 2.5 times 10 power negative 11 farad. Okay, and then number 2. The current in a hand calculator is very small, for example 0.006 milliampere. How many electron per second does this represent? So 2A, Q equal to NE equal to IT. So do you know how many electron per second? So N divided by T equal to I per E. So I is 0.0006 times 10 power negative 3 divided with 1.6 times 10 power negative 19. So it is equal to 2.25 times 10 power 15 electron per second. And then B, how long will it take for 1 coulomb of charge to flow? So Q equal to IT. So not T. So T equal to Q over I. So Q equal to 1 divided by I is 0.0006 milli, equal to 1.67 times 10 power negative 5 second. Okay, number 3. Determine the effective capacitance of the configuration shown below A and B. Assume that C1 equal to 1 picofarad, C2 is 2 picofarad, C3 is 4 picofarad, and C4 is 5 picofarad. Find the charge on each capacitor assuming there is a potential difference of 12 volt across each network. Okay, so we need to simplify this diagram. So first, we simplify C2 and C3. So simplify C2 and C3, it is a parallel circuit. So bila kita combine, the diagram will be the simplified one. It is C1 and C2 to 3. Okay. So we calculate the C from the first diagram. It is parallel. So when it's parallel, C23 is equal to C2 plus C3, where C2 is equal to 2 picofarad plus C3 is 4 picofarad equal to 6 picofarad. So this is C2 to 3. And then the next diagram, it is in series. When it is in series, 1 over C 1 2 3 is equal to 1 over C equivalent equal 1 over C1 plus 1 over C2 to 3. So equal to 1 over C1. C1 equal to 1 pico plus 1 over C23 is 6 pico. So we will calculate the answer and then 1 per kind of answer there. From the calculator, we got C123 is equal to 0.857 picofarad. Alright, so from your we calculate the charge. We go from the bottom one to the upper one. So this one in series apakah yang sama adalah Q. So kita akan tulis kat sini Q 1 2 3 is equal to Q1 is equal to Q2 3. So we calculate the first one, which is Q1 to 3 is equal to C123 V123. So C123 is 0.857 pico, and then V123 is equal to 12. So we got Q123 is 10.284 pico coulomb. And then kita naik ke atas, kita tengok yang bulatan yang pertama ni is parallel. So bila parallel, kita tahu dia ialah V23 is equal to V2 is equal to V3. So kita pemudahkan, kita kira V23 is equal to Q23 over C23. So Q23 boleh tengok kat bawah, dia sama dengan Q123. So Q123 equal to 10.284 pico. Divide with C23 is 6 pico. So pico cancel. So we got V23 is equal to 1.714 volt. Okay. So sekarang ni kita nak cari charge for each capacitor. So we can calculate. So Q1 kita dah ada. Q1 kita sama Q123 10.284 pico coulomb. And then how to calculate your Q2? Q2 kita boleh dapat daripada V2 dan V3. So Q2 sama dengan C2 V2. So C2 kita sama dengan 2 pico multiply V2 is 1.74 is equal to 3.428 pico coulomb. And then Q3 is equal to C3 V3. C3 is 4 pico multiply with 1.714 equal to 6.856 pico coulomb. So we got all the charge on each capacitor. Okay, next question B. So for the question B, we will combine C1 and C2 first. And then this is parallel. So C12 sama dengan C1 tambah dengan C2. C1 1 pico plus 2 pico is equal to 3 pico farad. And then we combine the diagram, so we will get and then we combine C34. Four pico plus 5 pico is equal to 9 pico farad. And then for the C1 to C34, we combine it will be series. So bila series 1 per C 1 2 3 4 equal to 1 over C 1 2 plus 1 over C 3 4 equal to 1 over 3P plus 1 over 9P. So we get what C1 2 3 4 is equal to 2.25 pico farad. Okay, so we know that from series capacitor, so charge dia sama. So kita boleh dapat Q1234 sama dengan Q12 sama dengan Q34. So we got Q total equal to C total V total. So C total tu Q total tu Q1234 lah. So C total kita ambil sebelah 2.25 pico. V total is from the battery which is equal to 12. So bila darab kita dapat 27 picocoulomb. And then we go upside. 3, 4 is parallel. So V34 equal to V3 equal to V4. So we calculate V34 is equal to Q34 divided by C34. So Q34 27 pico divided by C34 is 9 pico. Pico, so 27 divided by 9 equal to 3 volt. And then the upper side, so we got C212 equal to C1 equal to C2. So C1, so kita, bukan C pula. So kat sini V, bukan C. So V12 equal to V1 equal to V2. So we calculate V12 equal to Q12 per C12. So Q12 is equal to 27 pico divided by C12 is 3 pico. So you get 9 volt. 9 volt for V1 12. So kita akan kira the whole Q1. So kita boleh dapat Q1 equal to C1 V1. So you substitute C1 kita 1P darab dengan V1 kita 9 sama dengan 9 coulomb. So 9 picocoulomb. And then Q2 is equal to C2 V2. So C2 is 2 pico multiplied with 9 equal to 18 picocoulomb. Q3 equal to C3 V3 equal to 4P multiplied with 3 equal to 12 picocoulomb. And then Q4 equal to C4 V4 equal to 5P multiplied with 3 equal to 15 picocoulomb. Okay, continue with 4.2, charging and discharging of capacitors. So we know that figure A, charging process, it is a charging process. At t=0, the switch S is shown to the position 1. And then for figure B, discharging process occur. At t=0, the switch S is shown to position 2. So bermaksud kita punya capacitor ni dah disconnect from the battery. So kat sini kita tahu for the charging process, charge equal to 0 initially will be equal to Q dot. Okay, so finally dia akan jadi maximum. And then the formula is Q equal to Q dot bracket 1 by the exponent negative T over RC. For I pula dia akan jadi 0 sebab dia tak memerlukan elektron lagi selepas dia dah fully charge. Dan formula dia will be I equal to I dot exponent negative T per RC. Dan dia punya potential difference across capacitor for the BC is equal to V battery. So bersamaan dengan V maximum. So dia tak ada formula pun. Okay, for the discharging process, Q2 is equal to 0 for the final. So equation will be Q equal to Q dot exponent negative T per RC. And the I will be equal to 0 also. And then the formula is I equal to negative I dot exponent negative T per RC. Dan BC pun akan to 0 dan tak ada pun dash. So from the table A and B, sketch Q, T and IT graph for charging process. So di graph dia. And then this is your Q dot. And then for the graph IT, I dot. And then discharging. Eh, negative I know. So this is the graph for QT and IT graph. Alright, number 5. A 2000 microfarad capacitor is charged through a 1 kilo ohm resistor using a 6 volt supply. Calculate the charging current after 2.5 seconds. So I equal to I naught exponent negative T per RC. So I naught kita adalah 6 times 10 power negative 3. And then how to calculate, macam mana boleh dapat I naught? Oh, kena kira I naught kena kira dulu. So how to calculate your I naught? So we use formula I naught equal to V naught per R naught. So V naught kita 6 bahagi R dia ialah 1 kilo. So you will get 6 times 10 power negative 3 ampere. Barulah boleh kira I after 2.5 seconds. So 6 times 10 power negative 3 exponent negative 2.5 divide with RC. So kita terus kira tau kita equal to RC. R kita is 1 kilo ohm. Multiply with C 2000 times 10 power negative 6 equal to 2 seconds. So divide by, so you get your I is 1.72 times 10 power negative 3 ampere. And then for B, the charge on the plates after 2.5 seconds. So we use Q equal to Q naught bracket 1 minus exponent negative T per RC. So Q equal to, so Q naught tak tahu, so kita kena kira dulu. Q naught equal to C V naught. So C kita 2000 times 10 power negative 6. V dot kita 6. So sama dengan 0.012 coulomb. So kat sini kita ganti 0.012 bracket 1 by exponent negative. T kita ialah 22.5 divide with 2. So you will get Q kita adalah 8.56 times 10 power negative 3 coulomb. Okay, and then number 6. The duration of the photographic flash is related to an RC time constant, which is 0.1 microsecond for a certain camera. Okay, if the resistance of the flash lamp is 0.04 ohm during discharge, what is the size of the capacitor supplying its energy? So for A, so kat sini tau dia ialah 0.1 microsecond. And then R kita ialah 0.04 ohm. And then kita tak tahu C dia berapa. So kita boleh guna tau equal to R, RC. C equal to tau over R. So tau kita 0.1 dan 10 negatif 6. Divide with R kita 0.04. So you will get C is equal to 2.5 microfarad. And then for B, what is the time constant for charging the capacitor if the charging resistor is 800 kilo ohm? So we got tau equal to RC. So R kita still the same. R kita sama 0. Mana dapat? 800 kilo. And then C dia 2.5 micro. So tau kita 2 saat. Next 7. Using the exact exponential treatment, find how much time is required to discharge 250 microfarad capacitor through a 500 ohm down to 1% of its original charge. So 7. So kat sini kita keluarkan, dia bagi C kita 250 microfarad, R dia sama dengan 500 ohm, and then so Q kita sama dengan 1/100 Q dot. So we use the formula of discharging capacitor. So Q equal to Q dot exponent negative T per RC. So Q kita adalah 1 over 100. Q dot equal to Q dot exponent negatif. Nak cari T per RC kita kena darabkan, kita dapat 0.125. So Q dot and Q dot boleh cancel. So tinggal 1 over 100 equal to exponent negative T over 0.125. So you will get your T is equal to 0.576 second. And then for the last one, using the exact exponential treatment, find how much time is required to charge an initially uncharged 100 picofarad through a 75 mega ohm resistor to 90% of its final charge. So kat sini bila dia ialah charging, so kita akan tulis Q equal to Q dot exponent negative T over RC. So Q dot, dan kita tahu Q kita sama dengan 90/100. Q dot bersamaan dengan Q equal to 0.9 Q dot. So gantikan. T tak tahu, R kita berapa? 75 mega. And then C kita adalah 100 dan 10 kuasa negatif 12. So Q dot and Q dot cancel. So nanti awak lebih dapat T awak sama dengan 0.0173 second. Okay, so done. So saya harap anda semua dapat jawab dengan baik soalan PSPM for the chapter 4. Thank you guys.